Okay, here we go. We're going to pick up example 2, and we'll answer some questions. So Kaylee had a question how to do the last portions of her assignment. Raise your hand if you got all the problems done. Anybody? No, okay. Raise your hand if you got at least 2 of the problems completely done. Okay, so you're in good shape. Okay. Not necessarily. I'll show you that right now. So I'll show you some of those. Okay. All right. Yep. Question. Yep. And so after we do this, then we'll go straight to the things that you guys want to look at. We'll give those a glance. But right now I want to talk about this. Okay. So you don't have a lot of room on your paper. It looks like when I created new notes that I didn't leave a lot of space. So I think that the best spot for you to maybe fit this in would be, my notes are a little bit different than yours because I modified them. I think you have a little space at the bottom off to the side, right? So maybe that's where you want to do this work, okay? So we start here. It says a particle moves according to a law of motion, S equals F of t, for t greater than or equal to 0. Where t is measured in seconds and s is in feet, find the velocity at time t. How does the velocity function relate to the position function? The derivative. So I need to find the derivative of this. How do I find the derivative of this? I use the quotient rule. So let's go ahead and use the quotient rule. 4t minus 10 over t squared plus 3. So f of t is equal to 4t minus 10 over t squared plus 3. Okay, so I have that graph. And I want to find the derivative. So f prime of t is equal to the velocity at time t, which is equal to, we don't have to use the formal definition of the derivative anymore. The limit as h approaches 0. You're done with that. The only time you'll have to do that again is on your final exam. Okay? Yes. So, yeah, the derivative of the top, which is 4 times t squared plus 3, and then we will minus, what is the derivative of the bottom? 2t times the top, 4t minus 10. The bottom squared. Right here. The derivative of negative 10 is 0, so we don't have the negative 10. All right. Looks like we need to finish off the top. That's equal to 4t squared plus 12 minus 8t squared plus 20t. All over the quantity t squared plus 3 squared. Looks like we can simplify this a little bit. Okay, so would everybody agree that's my derivative? So that's the velocity function. 20t plus 12. So we've got v of t is equal to negative 4t squared plus 20t plus 12 divided by t squared plus 3, that quantity squared. So, how did I figure out the velocity after 3 seconds? Plug it in. Easily. So we've got negative 4 times 9 plus 60 plus 12, all divided by 3 squared is 9 plus 3 is 12, squared is 144. So negative 36 plus 60 is 24. 4 plus 12 is 36. One-fourth feet per second. I think I did that right. Anybody see a mistake? When is the particle at rest? Okay, I want you guys. We gotta be careful here, and this is where your algebra comes into play. Look at your function for my velocity. True or false? If the top is equal to 0, then the entire thing's equal to 0. Yeah. So do we have to worry about this bottom? Not at all. In fact, think about the bottom for a second, everybody. Is the bottom ever equal to 0? The bottom is never equal to 0. There's always that plus 3. If you square anything, it's going to be positive or 0. And then you add 3. The smallest value that you could get in the bottom would be 3. And then square to get 9. So the bottom is never going to be 0. The bottom's never going to be negative. So the bottom really doesn't play a crucial role in this at all, does it? Now, if it did, let's say instead of t squared plus 3 on the bottom, let's suppose you had this, t minus 1. Whoops. Forgot how to draw subtraction signs. Well, that's a whole different story. If you had t minus 1 quantity squared, well, it's equal to 0. It's equal to 0 at 1. Is it ever negative? No, because you square it makes it positive. But then if you switch it, let's say you had that on the bottom. Can that ever be negative? Well, it sure can. So you have to be careful with how to deal with those type of algebraic expressions. And I do try to remind you of your algebra. That's why we do a little bit more. I mean, we don't change anything today. The concept is exactly the same. The only thing that's different is we're trying to work through the algebra. So that's a lot of our problems in mathematics. So when is the particle at rest? I don't have to worry about the bottom. I take the top and simply set it equal to 0. And what can you factor out of the top? A negative 4. Negative 4 times t squared minus 5t minus 3. T squared minus 5t minus 3. Does that factor? No, it does not. So if it doesn't factor, what do I have to use? Quadratic formula. Fortunately for you, you put that in on your calculator, and you get t is equal to, can somebody put 1, negative 5, and negative 3 into their quadratic formula? If you don't have it, come see me. I can enter it. Nope. Nope, but give me the negative 1 anyways. Okay, so Emma came up with 2 results. One was 5.54, the other one was negative 0.54. So what does that mean? You can't have negative time in this scenario because the restriction, again, in our domain that we set out from the beginning was t was going to be greater than or equal to 0. So therefore, the only one that we're concerned about is time equal to 5.54 seconds. Yes, Elizabeth? Well, you sure could. Yeah, you could definitely have 2 positive ones, so it changes direction twice then. Yep. Yep, so in the homework, you could definitely have 2. Okay? When is the particle moving in the positive direction? Let's think about this, you guys. Okay? Would you agree that the particle is moving in the positive direction when the derivative is positive? Okay. Would you agree that the derivative is positive whenever the top is positive? Yes. So, let's answer that question. Negative 4t squared plus 20t plus 12 must be greater than or equal to 0. Well, not equal to, because when it's equal to 0, it's at rest. So, greater than 0. We're wondering where that shape is greater than 0. What shape does that make? It's a parabola. It's upside down. Do we know when it's equal to 0? We just solved that. When is it equal to 0? Negative 0.54 and 5.54. No need for tick marks. We're just trying to get a rough visual display, and it goes upside down, right? So, do you remember last year in pre-calc when we were solving quadratic inequalities and rational inequalities and stuff like that? That's the same thing that's happening here, okay? Is the derivative positive or negative right here? It is negative. This is the derivative. You're looking at the slope. This is the derivative. It is negative here. It is positive here. It is negative here. So therefore, the derivative is positive between, and can we include stuff on the left side of the x-axis? We can't include the negative numbers, can we? We have to exclude, this portion, okay? Because time is positive. So tell me, over what interval is this thing moving in the positive direction? From 0 to 5.54. That's when it's moving in the positive direction. When is it moving in the negative direction? From 5.54 to infinity, it's moving in the negative direction. Do you see how we've done that? Now, you guys, we could take the whole rational expression if that would please you instead, and we could set up some tables and we could plug in positive, negative stuff, but I've shown you how you can just sometimes look at the numerator and make that work, and I believe that that's how your assignment works out as well. Okay? So, this is actually a shortcut from what we could have seen the problem all the way through. Are you okay with that? So let's answer this question then. The question stated, when is the particle moving in positive direction? We said from 0 to 5.54. Correct me if I'm wrong, but this next part is the part that everybody had problems with, correct? Okay, so let's answer this together. It says find the total distance traveled during the first 8 seconds. Okay? So I'm going to start by drawing motion of the particle. Let's figure out where the particle is at the beginning when it starts. If we plug in 0, what do you get? Negative 10 over 3. Okay? So negative 10 divided by 3 is negative 3.33. So negative 3.33 at time equals 0. That's where the particle starts. Does it start by moving to the right, or does it start by moving to the left? It starts by moving to the right. You guys told me that it's moving in the positive direction from 0 to 5.54. So that's what I'm going to do. I'm going to start by moving in the positive direction. Well, Elizabeth, do you see how I know I'm at negative 3.33 at 0? I plug in 0 to the position function. I start by heading in the positive direction because from time 0 to time 5.54, I'm moving in the positive direction. So what we would expect that, and as we checked, in fact, the derivative is negative after 5.54. So therefore, we do know we changed direction. Yep. So that's what's going to happen. Now we have to figure out what. What's the next? What do we have to figure out now? What our position is at time 5.54. So, we could have done this right away. We didn't. Love those zebras. Who put that on my desktop? Is that you? Okay, great. All right, so if I'm going to take my position function, 4t minus 10, and we'll divide that by parentheses t squared plus 3. And so if this helps you, go ahead and enter it, then use your table values. Okay? So if I go to my table, I should type in 5.54. Whoop. Table set ask in 5.54. And I get 0.36. All right. Go away. All right. So it goes to 0.36. So we could call this 0, and it goes to here 0.36. And that's at time equal to 5.54. This is the position. So it's like instead of starting at the beginning or at the starting line, it started 3 meters back or something like that, however you want to think of it. Okay, so goes all the way up to 3.36. What does it do after that? It turns around. We want to know at time 8. Very good, Brooke. So now I'm going to plug in 8, and I get 0.33. What's that? No, we put 0.33. At time equal to 8. So as you see, the particle started out in the positive direction. At about 5.5 seconds, it turned around, and it didn't cover very much of a distance, did it here? Very, very small little distance, not much. So it must be moving very slow right now, right? And that's just what it's doing. So we need to figure out the total distance. So we've taken care of F. Now we're going to go back and answer E now that we've actually drawn it. Okay? So I like to break this up into segments. That's 0. So what's this distance here? 3.33. So I have 3.33. I'm going to add that to, what's this distance here? 0.36. And then how do you figure out that little sliver on the top? 0.36 minus 0.33 is 0.03. If we add that up, it looks like we get 4.02. What do you get? .72 feet. 3.72 feet. Oh, you wrote down 0.3 instead of 0.03? Okay. So that's the problem. Okay. Can I let you can I now let you go to work on your homework, and then tomorrow we're going to push through? I will work problems 5 and 6 together with you if you would like. Okay. All right.